we go. Today I can identify different parts of solids and find surface area. Surface area is not so bad. We've done the area of all of these shapes, and now we're just going to combine it together. The hardest part is visualizing, so I'll have hands-on activities as we go. We'll do hands-on activities as we go. Let's just define when I'm talking about a solid, we've got faces. The face of each solid is each polygon of the 3D figure. So when I'm looking at my hexagonal prism, the hexagon side is a face. This hexagon side is a face. Okay? So faces are each polygon of the 3D figure. The edges are each segment formed where two faces intersect. So again, if I'm looking at my shape in my hands, so like this is an edge where two faces come together. Technically, this is an edge where this face and this face comes together. Vertices, it's a point where three or more edges intersect. So like this would be a point, a vertice, because I've got this edge, this edge, this edge all coming together. A vertice. Questions? A lot of this first lesson is just introducing all the vocab that we're going to be using. Good morning, welcome. You're up front. Here you go.
Wait, what one?
Right there. All right. The surface area is the sum, put in parentheses, addition, of all the areas. Of all the faces or sides. So if I'm thinking about this hexagonal prism, I'm going to add one hexagon, two hexagons, and then going all the way around this hexagonal prism, what other familiar shape do we have? Square is too specific. Ava. What's up? Or sides. A rectangle. This is a hexagon. This is a hexagon. And then there is 1, 2, 3, 4, 5, 6. 6 rectangles. Does that make sense? Rectangles. This is not a perfect square. It's not a perfect square. So the surface areas, we're just going to add up all those faces. Are we okay with that? We're okay with that? I've got 6 rectangles. 2 hexagons. Why do I have 6 rectangles? 6 for a hexagon. Because there's 6 sides on the face. Now we're going to talk about a net of a solid. So here's an example. I just drew an example for you. Okay, the net of a rectangular prism. A net is a 2D pattern that can fold to form a 3D figure. Okay? So I drew one out for you. This is the rectangular prism. This is the unfolded net right here. That's the unfolded net. And you can see all the sides. Notice that some of them are equal. I know yours didn't print in color, but mine did. This side and this side are the same. This side and this side are the same. The same. So when it comes to these nets, you will have some of the areas be the same. Just got to kind of figure out and visualize it. The hardest part about this unit is visualizing the shapes. Are you ready for the prism? The prism is a 3D figure with exactly two congruent and parallel faces, and they are called bases. I would underline congruent and parallel. That's a vocab term that we love. Hi, you sit right next to Amelia in the front. Here you go. A 3D figure with exactly two congruent and parallel faces called bases. So I've been using my hexagonal prism for our example. If you've got a color pencil or a pen, I might color code this in. That's a base. And that's a base. Those are our bases. We've got six rectangular faces and two bases. How many sides in total for this hexagonal prism? 8. You're going to be asked that a lot, okay? So again, this is just an example. We're going to look at different prisms today. Questions? If you don't have a pen or a highlighter or something to shade with, will you grab a colored pencil? Right now we're going to do some coloring. Will you grab a colored pencil? Try and talk to your partner. Do they need a colored pencil? Take a second.